All right, so in this video, we're going to continue with our parent function notes. So it'll either be a linear, quadratic, absolute value, or exponential function. So as you can see, you have your table of data, you have your function on your coordinate plane. You also have your function algebraically here, okay? And it's going to be asking you for these quantities here. All right, so let's go through a couple of these. First of all, you should be able to look at example 1 and recognize that it's quadratic, okay? It's in the shape of a parabola. It is quadratic. You can also see here that it's x to the power of 2, which is quadratic, okay? And then you have your table of values. And remember how you got those table of values too. They're all there for you, but let's say that we didn't know the y for 0. We didn't know what our output was. Well, how would you figure it out? Well, you would do the math. In other words, I'm going to replace 0. So I'd have 0 squared plus 7 times 0 plus 6. Well, 0 squared is 0. 7 times 0 is 0. That's where the 6 is coming from, okay? All right, so x, y intercepts. Well, x, I have 2 of them, don't I? It crosses the x-axis in 2 places. So my x-intercept, I have -6, 0, and I have, it looks like -1, 0, -1, 0, okay? Y-intercept, it's right here, which would be 0, 6. Remember with your intercepts, if it's an x-intercept, your y is always 0. If it's a y-intercept, your x is 0. All right, and behavior. I'm going to put my arrows here. So remember, you're talking about the ends of your function in relation to the x-axis. So as x is approaching -infinity, my end is approaching infinity, okay, f of x. So y is approaching infinity. As x is approaching positive infinity, my f of x, or my y, is also approaching positive infinity. All right, interval increasing. So remember what that means. We are looking for our y values, and we're reading it from left to right, okay? And we're talking about them in relation to the x-axis. So from here to here, okay? I'm going from 10 down to -1. So my y values are decreasing. So in relation to the x-axis, it would be from -infinity to, and this looks like, 1, 2, 3, about 3.5, -3.5, okay? And then from here to here, my y values are increasing. So from -3.5 to infinity, my interval is increasing. All right, so let's look at the next one. Again, you should be able to look here and see that our x is our exponent. Also, the shape of our graph is going to let you understand that this is exponential. Okay? Now, remember, you're not going to have an x-intercept. This line is going to come very close to the x-axis, but it's never going to get there. Okay? It's never even going to get to 1. Here is our asymptote right here. So it's never It's never, ever going to go past, right here, 1. Okay? So, our y-intercept, though, would be right here, which would be 0, 2. All right, so let's look at our end behavior. So, as x is approaching negative infinity, our f of x, or our y, is approaching 1. Remember, that's that special case with exponential you have to remember. And as x is approaching positive infinity, our f of x is also approaching positive infinity. All right, so where is our interval increasing? Well, it's only increasing. It's not doing anything else but increasing. So it's increasing from negative infinity to infinity, and interval decreasing is not applicable. So number 3, look at it. It looks like a V. And you have these absolute value symbols there in your function rule. So you know this is an absolute value. Okay, now look for your x and y intercepts. Well, right here, it's going to be for both of them. So we have it at 0, 0, and our y-intercept is also at 0, 0. So let's look what our ends are doing. So as x is approaching negative infinity, our f of x, or our y, is approaching positive infinity. Okay? And as our x is approaching positive infinity, so is our f of x, our y. So where is our interval increasing? Well, you can see here on the left side that our y values are going down. So from negative infinity to 0, we are decreasing. But from 0 to infinity, we are increasing. And remember to read it from left to right. All right, and then let's look at example 4. This, you can see, is a straight line. We have x to the first power. This is a linear function. So let's look for our x and y intercept. So here's our x-intercept right here. It looks like it's at negative 9, 0. Actually, 2, 4, 6. Oh, actually, it's negative 8. Sorry, these are in twos. 2, 4, 6, 8. Negative 8. And here, 2, 4, 6, 8, 10. Okay, so then our y-intercept would be 0, 4. Okay, so let's look at our end behavior. So as x is approaching negative infinity, our f of x, or our y, is also approaching negative infinity. And as our x is approaching positive infinity, so is our f of x, our y. So where is the interval increasing? Well, as you can see, the whole thing is increasing. It's never decreasing. So from negative infinity to infinity, and it's never decreasing. All right, so why don't you go ahead and try the examples 5, 6, 7, and 8, and come and see me if you're struggling.